So is my screen visible? Great. So let's start today's session. So, mm, so welcome to the session on mm, joy of computing using Python. So I am Rupesh Kumar, and so hmm, I am Rupesh Kumar, and this is a tutorial session. Real session 6. It occurs every Friday, 6 to 8 p.m. It's Friday, August 30, 6 to 8 p.m. Fine. So in this week, you all have learned about the idea on minimax problems, how to design the tic-tac-toe game. Then you saw how to use encryption for transferring messages. So you saw some basic. First, you saw about the string library in Python, how strings are, how you can do string manipulations in Python, and then you saw how to encrypt strings, basically how to change the message strings into some format that cannot be decoded by a middleman, and then you can pass your transfer your messages without any issues, and with obviously with security. And then the next thing you saw it was what is how you learned about the tic-tac-toe game. So how to program a tic-tac-toe game, and how what is the objective of a tic-tac-toe game. Basically, you want to maximize the chances of your win and minimize the chances of your opponents. Minimize the chances of win of your opponents. And then you learned about recursive functions, how they are used, how in which scenarios recursion can be useful, right? So in this session, I will go through with some basic examples on these topics, and then I will take queries from you guys, right? So I'm starting the session. So just to be sure, are you able to hear me, and is my screen visible? And everyone, just type in the chat box. If you can't, just type in the chat box. Great. So let's start with the first problem. So let's see what the problem says. So we are defining a function. So let me open up the Spider console. So I hope by now every one of you is using Spider uh, IDE for writing your Python code. So this is the IDE that we have been using since the beginning of this course. So it's not fine. Fine. So this is how your Python IDE looks like. So let's open up the console, run docket. So here is your IPython console. So you can find it on the right hand side of your screen. I prefer it undocked because so you can just expand it like this and you can see the values. So let's zoom in the console. Yeah. So let's get back to our first problem. So let me copy this question in the Python console, and then we can solve the problem. So def keyword is used to define functions in Python. So def, the syntax is def followed by a function name. Then you use this small braces to define that you are going to define a number arguments for this function. Then you use colon to define the that the from the next line onwards, everything is a function is the function boundary. We use tabs or indentation to specify blocks in Python. So here we are using one tab gap to define the function block. Fine. So we have the if statement. If n is less than 2, then what we have to do? We have to return n. Else what you have to do? You have to return my3 n minus 1 plus my3 n minus 2. So let's see. So it is a recursive function. So first of all, let's talk about recursion. Is my screen visible, everyone? I mean, the code I'm writing is visible. The text is visible to you all. Great. So let's talk about recursion. Recursion. So a function is called a recursive function if it calls itself. So in this example itself, you can see it's a recursive function. So we are defining the my mystery function, and within the mystery function, we are calling it again. So that's why it is a recursive function. So, so this much is fine, Gurman. So this much size is fine. Text size, fine. So when we talk about recursive function, it is a function that calls itself. So you can see the function mystery is being called by itself in line number 15 here. Fine. So there are some basic important conditions for recursive function. Let's say if I write a simple example of a recursive function. So let's call it def recursive, and it takes some input n. Then what we have the most important thing here is we have a base case. So yeah. Okay. So there is a base case. So it is important. It is important as it ensures that the program exits. So let's say, and then there is auxiliary case. What it does is uh, do some com computation and call the function again. Fine. Yeah. And then there are other cases also. Other cases. So basically, the most important blocks are these two blocks, base case and the auxiliary case. The base case ensures that the program exits. So let's say if I write a recursive function like this, def recursive, and let's say what I do is I ignore the base case and I pass n by 2 again. Fine. Now let's say if I call recursive with input 100, let's see what happens. So you see it says maximum recursion length x depth existed. Everyone, can you see this? Can you see this error that I have obtained here? So it says maximum recursion depth exceeded. So let's see what it says. Maximum recursion depth exceeded. So let's see where can I look at? So this is a solution from Stack Overflow. It says that it's a guard against a Stack Overflow. So what it does is it basically checks if so whenever you run a program, some memory is being allocated from the heap, so stored in the heap and the stack, and then when you call a function is called, then the function pointer is being stored in the call stack. So when you call a function infinite number of times, then it gets filled up and it results in some issues. So there is a check in Python that checks this. If maximum recursion depth is exceeded, then the program exits. So this is the issue that we face. So why this was happening for this function? Because we did not have any base case that 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 ensures that the program exits. So let's define a base case for now so that our function works. Let's define a base case. So if n is 0, then what we have to do? Return maybe let's say true, and let's see what happens. Sorry. And then we can simply we return true, and let's define this function. Okay. So let's call this function again, and let's input 100 here. So you can see the program exits. So let's print the value that it returns. So it returns. Acha, so we need to return some value in each function call. So we haven't returned any value from the auxiliary cases. That's why we are not getting any output. So let's rewrite it. So basically in the auxiliary cases also, so if this else, we have to simply return the value returned by the function recursive again over the value n double divided by 2. Here a double front slash states the integer division operator. So let's call this function again, recursive, and you will see it will print true. For any value you pass in, it will return true because we are doing integer division, and for any number dividing it by 2 eventually will result in making the number equals to 0. So this is how we define a recursive function. Fine. So let's go back to our first program. How does it work? Let's start. So let's say if I call the function mystery with some value n. Fine. So what happens? It checks for the value of n. Is so it basically checks is n greater less than 2. If that's the case, it simply return the value. So it returns n. Otherwise, what it does, it calls the function mystery n minus 1 again. Mystery with the value n minus 1 and mystery with the n minus 2 again. So let's see some chart. We'll see. Let's look at the stack, and then we'll see something. So yeah. So So there is a mistake. So somehow I make it too large and it's now it's fine. Let's look back at the question. The function, what is the function? It says it defines a function mystery. So let's hmm. So I don't know how to enter text here. Fine. Let's just ignore it. So we have a function mystery. So let's call it m. Let's rename our function to m. Fine. So we have a function. Okay, why it is. Hmm. Hmm. So let's call our function mystery. It takes an input m, and what it does, it checks. Okay, so we have this mystery function that takes an input n, and then what it does, it checks. What it checks is, and if n is less than 2, if n is less than 2, then what it does, it simply returns n. So what we need to do, return n. Right? So if that's the case, it returns n. If n is not less than 2, then what it does? If n is greater than 2, then what it does? It, it calls the function mystery n minus 1 plus mystery n minus 2. Now, let's see what happens. Then again, when you call this mystery n minus 1, then what happens? It again checks if 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 n is, how to move it? If n is less than 2, or if n is greater than 2, and then n or returns this. Fine. So this is what it do does. Okay. So let's edit this. So it becomes n minus 1 here. Similarly, this becomes n minus 1 because the input was n minus 1, it returns n minus 1, or it returns n minus 2 and n minus 3. And this same thing happens for this other side of the loop also. It's just the difference is that let me take this pencil, and this function call does this, and just the difference is it's n minus 2. So let's move it here. This becomes n minus 2. This becomes n minus 2. This becomes n minus 2. And this becomes n minus 3 and n minus 4. So, and so on. And this cycle repeats until n becomes less than 2. Fine. So this is how this program will run. So let's say n was, let's say our input n was 2. Then what would happen? Let's say n was 1. Then what would happen? It would have returned 1. Fine. So now let's say, and if we enter n equals to 2, then what would happen? It sees that n is not less than 2, n is greater than 2. So then what we would do? It would call the function mystery with the value n minus 1 plus n minus 2. So mystery with n minus 1 would be mystery with, it would be mystery with n equals to 2 minus 1, that is 1. And then again, mystery with n minus 2 is basically mystery with n 2 minus 2, that is 0. Now, again, mystery call to with n equals to 1 would result in uh, n minus 1 equals to, so basically n minus 1 equals to 0. So it would return n minus equals to 1. So it will return 1, and this will again return 1. Uh, 0 here, so it will return 1. So the final answer would be 1 if we call this function. Fine. So this is how this function works. So let's see. Let's call this function with the value 2. Let's see what it does. So let me print the value. So it returns 1. So yeah, our intuition was correct. So first it will solve the left-hand side of this recursive call and get the value. Then it will go to the right-hand side of this recursive solve and solve the value. Fine. So let's see what the program says. What is the input? The input is n equals to 25. So we have to run this program for n equals to 25. So let's pass 25 here and let's see what is the output. Let's run it. And you can see the solution is 75025. Fine. So you can see the correct answer is option B, 75025. So do you guys remember this problem? It looks similar to the Fibonacci sequence, where in the Fibonacci sequence, nth number is basically sum of previous n minus 1 and n minus 2th number. Do you remember this? So let's print these values and see what is happening. Let's ret val equals to this, then print ret val, then return ret val. And here let's print n. let's call it for 10, maybe. Okay. Um, so similar to that problem. Fine. So anyone do you have any doubts with this problem? How did I decode this problem? Anyone do you have a doubt with the problem number one? How did I decode? Did we solve this problem? What's the logic behind it? So every time you call a recursive function, it first checks for the base case. If a base case is true, then the program exits. And now in the auxiliary case, what you do, you call the recursive function for the modified input. So here the auxiliary function call was mystery with n minus 1 plus mystery with n minus 2. So what will happen is now this function mystery with n minus 1 will be solved until n becomes less than 2. Then again mystery n minus 2 will be solved until n becomes less than 2. And then these both return values will be added up and returned. Fine. Great. So let's go to the next question. Which method in Python is used to convert lowercase letter in string to uppercase? Anyone? Can you answer this problem? So which method do we use in Python to convert lowercase letters into in a string to uppercase? Nice. So the correct answer is option A. Upper function is used to convert lowercase letters into uppercase. So let's say we have some str like this, str equals to A, B, C, D, and I want to convert to uppercase. So just call to upper. Wait, oh, sorry. The function is upper. So you can see it returns A, B, C, D. Fine. So let's go to the next question. Uh, the min-max strategy, often referred to as minimax algorithm, is a decision-making algorithm used in game theory and AI. It is commonly employed in two-player games with alternate turns and perfect information, such as chess or tic-tac-toe. What is the primary objective of the min-max algorithm? So can anyone tell me? So with the in the tic-tac-toe example, what did we want to do in the tic-tac-toe example? What was the case? So we have a 3x3 board like this, and there are two players, player X and player O. They play one by one, and after each play by any of the players, three things are checked. Either the values lie along a row that are completely the moves of player A. So let's say X, 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 then player X wins. Or along the same happens along the commons, for example, X, X, X along the columns, or it happens along the diagonal, that is X, 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 same thing like this. So then the player X wins. Otherwise, then there, what are the possibilities in this? Either X wins or O wins or none of them wins. So there are three possibilities in this case. With every move, what does the player want to do? The player want to maximize. What does the player want to do? They want to, so they basically want to minimize the maximum possible loss to their game. So that is what the minimax algorithm says. The correct answer is option C. It tries to minimize the maximum possible loss that the player can obtain. So the player want to minimize their loss. So how do that? In these such of problems, in where there is a player, there are two players involved. Each player want to minimize their own possible loss, right? Using the min-max strategy. So you want to minimize the maximum possible loss, fine? Let's move on to the next question. Typecasting. So yeah, typecasting refers to the conversion of one data type to another. Python provides several built-in functions for typecasting, such as int, floats, str, list, tuple, set, and dict, among others, to convert between different data types. What would the output of the following code? So here we have a we have a num str. So we have this variable num str that contains an input string that contains 123 BABU Babu Moshai. Fine. So what we are trying to do in the second line, we are trying to convert it to integer using the int explicit function and typecast, and then we want to print the value num. Fine. So this is the function. This is the code block that we see, and we are trying to explicitly typecast the number num str into integer. So wherever you are trying to do explicit typecasting, it makes sure the argument to the function for explicit typecast should belong to that data type. So here the our input argument is 123 Babu Vanshai, which is not entirely an integer value. So it will not convert it to any integer integral value. So it will throw out an value error. The input value is incorrect. Fine. Option B, which is fine. So you can't do such typecasting. So yeah, if it was num str equals to 123, then the output would have been 123. Fine. Fine. So let's move further. So what term is used in programming languages when function calls itself? So when we started this session itself, I asked you a question, what are recursive functions? So you already know the answer to this function, to this question. Recursion, correctly. When a function calls itself, then it is the function, then we call that the function is recursive function. Option C, which is recursive. Let's move on to the next question. Consider the following snippet of code. Def function which takes in an input list L. If list is a blank list, then return 0. If list at 0 modulo 2 is 0, then return 1 plus func and the remaining list. Otherwise, return func L and the remaining list. So I hope by now every one of you are familiar with lists. So let's say I have a list L. It contains some values, some integer values. So let's say it contains 1, 2, 3, 6. So let's say it contains these values. So you can access all the values present in this list using square bracket followed by some index. So let's say what is the value stored at index 0 in this list? It is 0. What is the value stored at index 4? It is 4535. Fine. Now let's say you want to extract some substring from this list. So what you can do, you can use the colon operator. So when you call a list with this colon operator without passing any arguments to this colon operator, it returns the entire list. If you pass an argument to the left hand side, it returns the list elements list, the sub list of this list with containing the elements starting from the index specified at the left hand side. Currently it is 1, so it will return everything including the values presented from the index 1. So let's run this and see what happens. So when you run this, you can see it returns a list containing the elements 2 till the last value. So you can see 1 is ignored here. So now if you don't pass any starting index, but you pass the end index, then what it will do? It will return the first row of the list up till that index. Fine. So you can see the output here. You can also pass both the starting and end index. So it will return the values between those index. Fine. So make sure when we talk about upper limit to the indexes here 4, so it basically means return values until index 3 including. So it includes index 4 here right now. Okay. So fine. So these are lists and these are the slicing operations. So let's go back to our problem. So now let's say L is the non-empty list of positive integers. Then which out of the following statement is correct about the above recursive function func L? Fine. So let's see. So let's first see what the function does. If so, let's talk about the base case of the recursive function. It says if L is a, so this means if the input list is a blank list, we have to return 0 and exit. Then let's move on to the, let's copy this. Let's copy this here. So this was our base case. So now let's see case 1 where L, the value at the starting index modulo 2 is 0. That means the first value stored in the list is even. So what we have to do? We have to return the value 1 plus another function call over the list L again containing the sub list, so containing the elements starting from the index 1 until the end of the list. Fine. If that's the case, in the case 2, what it does, it checks, it does not checks anything. So basically, the first value stored in the list is odd. Then what it has to do to return? It has to return func, the function again, a recursive call to the function again, with the sublist containing elements starting from the index 1. Fine. And then the function gets called. So let's take an example. Let's say our list L contains the values that we used here itself. And let's paste those values here. Fine. So let's say this is our string. Then what does this function do? If so is L, so let's talk about the recursive call 1. So L is not blank list. So it goes to the first condition. So it checks L at 0, which is equals to 2 here, and it is even. So what it returns? It returns again 1 plus function call at list at elements in the list from index 1 up till end. So it becomes 4. So let me copy the elements here. So this function call again. So now what this function call does, let's see. So it's a recursive function call. L is not empty. So we repeat the steps again. Then check L at 0 equals to 4 is even. So what we do? We again return 1 plus function call to the list elements in the list starting from the index 1. Fine. Then again, it's a recursive call. So let's resolve this function first. What it does, list L is not empty again. So what it will do? So let's cut short the list up till 4 elements only. So it will take a lot of time. Fine. So the list is not empty. So let's check the value stored at the index 0. L at 0 is 76, which is even. So again, what we have to do? We have to return 1 plus function call with the elements in the list, excluding the first element. Fine. Now again, what we have to do? We have to check L is not empty. So let's reduce one more element. So let's try to get the answer. Fine. So L is not empty. Then what do we check? We check the value at L at 0, which is 4535, which is odd. So what we have to do? We have to go to the case 2 that returns function call with list element starting from the index 1. So what it does, it returns func with. So function, the list now contains only one value. So from index 1, it will return a blank list because there are no remaining values. So it returns blank. So now what it does, it's a func. So again, let's resolve this function call. So L is empty. So what we have to do? We have to return simply 0. So let's backtrack our function call. So from this call, we get 0. So we can replace this function call with the value 0. So this is the outcome. So it returns 0 here. Then again, let's use that return value to this function call. So this function call func4535 returns 0. So let's put 0 here. Then again, this function call, let's go to this function call. It returns 1 plus 0, that is 1. Then again, let's go back to the initial function call. It returns 1 plus the value returned by this function call, which is 2. So finally, our main function call returns 1 plus 2, which is 3. So what is 3 here? 3 is the total number of even values present in the list L. Fine. So this is how to decode recursive functions. So the correct answer is option B. It returns total number of even elements in the list L. So anyone? So someone is saying video is not available. Is that the case for everyone? Do you have any doubts? 1 plus 2 equals to 3. Okay, fine. So here this function call returns 2. Fine. So it returns 1 plus 1, which is 2. And finally, 2 was even. So this main function call, this was the main function call. So let's call it func with the over the main list. So this was the main function call. And this call returns 1 plus 2, which is 3. So do you have any doubts? Fine. So if you have any doubts, type in the chat box. So fine, it seems that no one has any doubt. So let's move on to the next question. Um, so if you have any doubts, please type in the chat box. Right. So let's move on to the next question. So we have again we have another recursive function. So now let's see what it's doing. So let's decode this question again. So it's again a recursive function. And let's see what so n is a non-empty list of positive integers. So let's see what is the correct about this function. So let's again use the same strategy. So let's say our function L. Let's take let's take the list from the previous problem itself. Fine. So let's call the function func L. Fine. So what it does, L is not empty again. You can see. So what you have to do? We have to check L at -1. So everyone, are you familiar with this -1 index notation? So let's say this is L or L. So then L at -1 essentially means basically this means is the value at length of L. So -2. The element present, the second last element. So -1 essentially means the second last. So it essentially means the last element. So length at L -1. So L at -1 essentially means the last element from the list. Fine. So similarly, at L at -2 would be the element at the second last element. So that would be 67567. So this is how negative indexes work in Python lists. Fine. So L at -1 is essentially 4535, and it is odd. So this is not modulo 2 is equals to 1. So what we have to return? We have to return. So we have to return L at -1. So basically the last value, which is 4535, plus the function call again with the list containing elements up to the second last index, that is 2476. So let's call this again with this list. Then again, what is L is not empty. And then L at -1 is essentially 76 here, which is even. So for even cases, what we have to do? We have to return function call with the list elements in the list up to the second last element. So 2, 4. So again, you can see L is not, mhm, L is not empty. And we can see L at -1 is essentially 4, which is even. So what we have to do? We have to again return function call L with in excluding the last element, so which is 2. Then again, this is L is not empty. Fine. and L at -1 is essentially 2 because we have only one element here, which is or even. Now what we do, we again do a function call with the list containing removing the second last element. So only 2 was there. So now the function will be called with a blank list and L is empty. So what we have to return? We have to return 0. Fine. So everyone, do you understand this? What is doing here? So now this function call returns, this function call returns 0 here. So this function call returns 0. Now what this function call returns? This function call returns again 0 here. Fine. So now let's look at this function call. This function call again returns 0. Let's go back to the top function call here. It again returns, it returns 0. Fine. And finally, this function call. Let's see what this function call returns. It returns 4535 plus 0, which is 4535. 4535. Fine. So this is what this function returns. It essentially returns the sum of odd values, odd positive integers present in this list. Everyone, can you follow this? So if the element at the last index is odd, then return that element plus the remaining part, the list with excluding that element. If it is even, just return 0. It's basically adding up all the odd entries in the list. Fine. So let's look at the options. Option C, option D, it's basically option D. It returns the sum of odd elements in an. Option D, it returns the sum of odd elements in the list L. Fine. Anyone? Do you have any doubt? Hello. If you have any doubts, please type in the chat box. If you have any doubts, please type in the chat box. So this is how you resolve dry run recursive functions. Fine. Let's move on to the next question. So what purpose does a base case serve in recursive functions? So I hope by now every one of you have answered to this question. So what is the use case of base case in recursive functions? Correct, option C. So the main the base case in a recursive function is important to ensure termination. Fine. Let's move on to the next question. This is again a question on recursion. So we have this function. If n is greater than 1. So let's solve this problem. Again, this is a recursive function. So Let's see what is the value of f. 1000, 10,000. No, okay. So basically you can see n is greater than 1. Yeah. Then it checks if n divided by. So in this line, you can see it says if n double multiplies asterisk. So what is double asterisk operator in Python? So let's say we have 2 and we type double asterisk c. So it essentially means 2 raised to the power of 3. So 2 raised to the power of 3. Fine. So this is what double asterisk says. And this if condition says if n modulo zero point 0.5 n raised to power 0.5, so square root of n is equal to its integer of square root of n. This means it is a perfect square. If n is a perfect square, then we have to do something. This is the first condition. So let's see. So n is basically 10,000, 10,000, and the square root of 10,000 is basically, so n raised to power 2 is 100 basically, which is an integer. So it is a perfect square. Then what we have to do? We have to simply return 1 plus function of integral part of n raised to power 1 by 2, which is 100. So now let's resolve this recursive call again. F is 100, 100 is greater than 1, and then check the n raised to power 0.5. So 0.5 here. Let's check the value and raised to power 0.5, which is equals to 10 here, which is an integer again. So again, the if condition gets executed and we return. So we return 1 plus f of integer of square root of 10, which is 10. So let's resolve this function call. F of 10, 10 is greater than 1, and raised power 2 is approximately equals to 3.2, which is not an integer. So what it does, the if condition fails, it goes to the elif condition. So elif n modulo 2 not equals to 0. So it says n modulo 2 not equals to 0 means n is an odd number. So no, n is an even number. So n modulo 2 equals to 0 here because n is 10 right now. So this condition fails, then the last else condition gets executed, which is return 1 plus function of. So it essentially returns return 1 plus function of and integer part of n by 2. So integer part of n by 2, which is basically, that means f of 10 by 2, which is 5. Fine. So let's resolve this value f of 5. So you know f is not a perfect square. So 5 is not a perfect square. Then again 5 is odd. So if 5 is odd, what we have to do? We have to return 1 plus f of 3n plus 1. So we have to return 1 f of 3 into 5 plus 1, 3n plus 1. So let's resolve this function call, which is f of 5 3 15 plus 1 16. 16 is a perfect square, so we have to return 1 plus square root of that. So 1 plus square root of 16, which is 4, f of 4. Fine. So now 4 is greater than 1. 4 is a perfect square. So what we have to return here? F of 4 is basically 1 plus f of 2. Fine. Now what is f of 2? 2 is not a perfect square, but 2 is even. So what we have to return? We have to return 1 plus f of 2 by 2, which is 1. So 1 plus f of 1. And now what is f of 1? F of 1, if n is, so n is not greater than 1 and n is not less than 1, n is equals to, then we have to return 0. So this f of 1 call returns 0 here. Fine. So this function's returns f of 2 returns 1 plus 0, which is 1. So f of 2 returns 0 plus 1, which is 1. Then f of 4 returns 1 plus 1 plus, so it is 2, it returns 2. Then again, f of 3 into 5 plus 1 returns 2 plus 1, 3. Then let's backtrace. So this function call returns 1 plus 3, which is 4. Then again, let's backtrace. This function call returns 4 plus 1, which is 5. Then again, let's backtrace. This function call returns 5 plus 1, 6. And the final function where return value is 6 plus 1, 7. The final answer is 7. So what is the value returned by function of 10,000? It is 7. Fine. Anyone, do you have any doubts in this problem? So anyone, do you have any doubts in this problem? Just type in the chat box. Great. So will you be able to solve this problem? F of minus 8. So what doubt do you have, Sasmita? Just type in the chat box. So please type your doubt in the chat box. How the answer becomes 7. So, so let me write the cases for this function call, and then you can see you will get the correct answer. So what is the function doing? So whenever you call the function over a value n, it checks if n is greater than 1, and then it checks if n is perfect square. Then what you do? It returns. Then what value you have to return? You have to return 1 plus f n square root of n. Fine. Else, if n is odd, then what you have to return? You have to return 1 plus function value of 3n plus 1. Fine. Else, if n is even, what you have to return? Return 1 plus f of n by 2. Simply. Okay. Fine. Now, else, if n is less than 1, what we have to return? We have to return 1 plus f of n squared, n into n, basically. Fine. Else, the last condition is if n is 0. If n is 0, we have to return 0. Fine. So these are the basic conditions for this function f. Okay. So now initially you make a call with 10,000. So 10,000 is greater than 1 and 10,000 is a perfect square. So what we have to return? 1 plus square root of n. So 1 plus square root of n, f of square root of n. So f of 100. 1 plus f of 100. Then again 100 is greater than 1 and a perfect square. So we do a call again, now do a function call 1 plus f of 10, which is square root of 100. Now 10 is greater than 1, but it's not a perfect square. So then we check if 10 is an odd number. It's not odd, it's an even number. So what we have to do? 1 plus f of n by 2. So we call it 1 plus f of 5, which is 10 by 2. Now 5 is again not a perfect square, but odd integer. If it's odd integer, we have to call 1 plus f of 3 into 5 plus 1. Now let's decode this function call. 3 into 5 plus 1 is 16. So 3 into 5 plus 1 is 16, which is a perfect square. So what we have to do, we have to return 1 plus function call of square root of 16, which is 4. Let's decode a function call of f of 4. Again, f of 4, 4 is even square root of x square. So we call it 1 plus f of square root of 4, which is 2. Now 2 is again greater than 1, and 2 is not a perfect square, and 2 is even. So we do a function called 1 plus f of 1, which is 2 by 2, 1. And f of 1 is basically 0. If n is 1, then we have to return 0. So this last function call returns us a value 0. Then the second last function call returns a value 1 plus 0, which is 1 that I have stated here. Then again, the third last function call returns the value 1 plus 1, which is 2. It comes here. Then again, the fourth last function call returns the value 2 plus 1, which is 3 here. Then the fifth last function call returns the value 1 plus 3, which is 4 that you can see here. Then again, sixth last function call returns the value 1 plus 4, which is 5 here. Then seventh last function call returns the value 5 plus 1, 6, which we get here. And the eighth last function call, that was the first function call, it returns the value 6 plus 1, 7. So this is how you decode this problem. So Sashmita, do you have this doubt again? So you basically start tracking the function calls and achieve the final answer. So do you have the doubt again? Hello. So please type in the chat box if you have the doubt. Uh, So why we use like one plus in return statement? It depends upon you. So in this program, the user is trying to count something. So it is using one plus f of 3. It depends, totally depends on the problem. It totally depends on the problem you are trying to solve. For example, in the previous example, we were trying to count the total number of even numbers in the list. So that's why we are using 1 plus func L. So it depends on the problem, no? So here we wanted to count the number of even numbers. So that's why we did return 1 plus func of 1 plus recursive call. So in the next problem, we wanted to add up all the odd numbers. So here we did not use 1 plus, we used the odd number plus the recursive call. So it depends, totally depends on the problem. It's problem specific. Fine, Saket? No, it depends on you, na? So let me give you an intuition. So it depends. Now, let's say you have a list 1, 2, 3, 4, something random list like this. So what you do? Let's say if I want to count the total number of even numbers in this list. So let's create a count variable. Count equals to 0. And then you loop through the list for I in list L. Let's say if I modulo 2 is 0, what we do? So what we do? We simply update the count variable. Count equals to count plus 1. That's it. And when you print count, you see it returns some number of even numbers. So it totally depends on the problem. If you want to count, you count. Let's say if you want to sum the total number of elements, so you don't need 1 here. You need to add up I here. Then you will get the total sum of the even values present in the list. So it depends on the problem. Yeah. So in counting problems, we usually use 1 whenever we find the desired value. Fine. So let's get to the last question. So again, the last let's take up this logic here. We'll be reusing this logic for the last problem also. So what is the value returned by f of minus 8? So let's do this function call. So minus 8 is less than 1. So what we have to do? We have to return 1 plus f of n into n. So minus 8 into minus 8 is 64. So let's resolve this also. So 64 greater than 1 and perfect square. So what we do? We return 1 plus f of square root of 64, which is 8. Now 8 is greater than 1 and not a perfect square and even. So what we have to return? We have to return 1 plus f of 8 by 2, which is 4. 4 is greater than 1 and perfect square. So what we have to return? We have to return 1 plus f of 2, which is square root of 4. Then finally f of 2, 2 is greater than 1, not a perfect square and even. So what we have to return? We have to return 1 plus f of 2 by 2, which is 1 here. Now if f are 1, so we have to return simply return 0 here. So let's see what are the return values. Let's trace back. So this function call returns 0. This function call returns 1 plus 0, which is 1. This f of 8 by 2 returns 1 plus 1 plus 1, which is 2. Then f of 8 returns 2 plus 1, 3. Then f of 64 returns 3 plus 1, 4. And finally, f of minus 8 returns 1 plus 4, which is 5. So the correct answer is 5. Fine. So by now you will be able to solve these recursion problems, everyone. Everyone, do you have any doubts in this recursive problems? Just type in the chat box. Great. So these are all some basic problems on these topics, strings and recursion. So now I have some basic some programming problems that I will solve for you guys. So that will begin. So let's take a break for maybe 5 minutes. Let's meet at correct. So let's meet at 7:25. Till then, type your queries in the chat box. Fine. Everyone, let's take a break. So, hi everyone, welcome back. So, let's solve a few programming problems. So, do you have any doubts in the just type in the chat box if you have. So, if you have any doubts, just type in the chat box. Right. So, let's solve some programming problems. So, let's start with some basic problem and then I will move on to advanced problem. So, write a program to check whether a string is palindrome or not. So, let's talk about palindromic string. So what is a palindromic string? So let's say we have a string like this, A, B, C, D, E, F, G, E, D, F. Let's say it's a random string. So it is not a palindrome. What is a palindromic string? So race car is a nice example. Race car is a palindromic string. So what is a palindromic string? So if a string and its reversed string are same, then it is a palindromic string. Fine. So for example, in race, the reverse of race car would be RACECAR. So it's a palindromic string. So let's take a simple example. Let's say ABC. It is no, it's not a palindromic string. So now let's talk about ABA. Yes, it is a palindromic string. So see, just these type of strings are known as palindromic strings. So how would you solve these problems? Let's say I have given a string like this. You have to check if it is a palindromic string or not. Can anyone tell me some logic? Can you help me out? So you are saying if a so essentially you are reversing the string and simply checking. So yeah, it will work. Fine. So let's say we can also use string dot reverse. Let's say I have a string s equals to something, then I can use the function s dot reverse. I don't know if reverse is a function in string. I don't know if reverse is a function in Python string. You can look up to that. But let's say we don't want to use any function or this like these functionalities. Then how would you do it? If I want to write a let's say recursive function to do this, how would you do it? So let's try to solve it. So def, let's define a function, is palindromic. It's palindrome. Take a string s. Fine. Then what is the base case? What is the base case? Base case would be string is empty. Fine. If f is empty, s is empty, empty, what we have to return? We have to return. So let's ignore the base case for now. First write the auxiliary cases and then. So if the start the first character in the string is equal to the last character in the string, then it means that at least the first character and the last character are matching. So basically, when you talk about palindrome, you say the first character should be equal to the last character, the second last character. So the first character should be equal to the last character. It's like A, it starts with A and ends with B. Then let's extract the substring, ignoring those two parts. And if again this string is a palindromic string, then this is a palindrome. So let's check the first and the last character, they are same. So let's again extract the string in between. So we're essentially removing the first and the last characters, first checking if the first and second last and the last characters are same. If they are correct, if they are same, then this string might be a palindromic string. If they are not same, then for sure the string is not a palindrome. Now, if this is the case, we have to check for the string that is the string that is inside that is sandwiched between these two characters. So we can check this middle substring. Now again, you can see the first and the last character are B in this, and so this might be a palindromic string. And we have to check again the middle part. Again, we can see for this substring, the first and the last characters are B, which are same. So it might be a palindromic, and we need to check the middle part. So what is the middle part here? So we remove the first and the last character, and we can see this string, the first and the last character are C, so they are same. So again, this might be a palindromic, and we need to check the middle part. So we need to remove the first and the second half, first and the last character, and then see the string here. So again, first and the last characters are same. So this might be a palindromic string. What we need to do, we need to check the string left after removing the first and the last character in the string. Again, you can see the first and the last characters are same. So what you would like to do, you would like to check the middle part of the string. So remove the first and last character and check. In this string, you can see the first and the last characters in the strings are same. So this might be a palindromic. Now remove the first and the last string. You will get an empty string. So when you get the empty string, what you need to do? You can simply return. If you reach to this part, if you reach that you are able to remove all the characters of the string after checking the first and the last characters in every part of the substring, and you are able to get the empty string, then this means there were no such case where the first and the last characters in the substring was not equal. So it is a palindromic. So what you have to return? Return false. Now let's say this was, let's say instead of this B, it was a C. So let's change it entirely. I guess this and then this. So till this part, it might be a palindromic skin. For this part also, it might be a palindromic skin. But for this part, you can see C is not equals to B. So here you would have returned false. So fine. So this is how I guess we can write our program. Fine. So if you are able to reach the empty string, then it is a palindromic, else it's not. So if we reach the empty string, it is palindrome. Fine. If not, else if the first is equal to the last character, then it might be a palindrome. Check for the list obtained after removing the first and the last characters. Fine. Else, if the first and last characters are not same, the string is not a palindrome and return false. Fine. So this is the recursive logic that we'll be using to solve this problem. So let's go back to our Spider console. So let's solve this. Let's call it palindrome, palindrome recursive. Fine. So let's zoom in a little bit more. Let's create a function. Def is palin, it's palindrome, input a string. Now let's type in the base case. What is the base case? If s is an empty string, then if it is an empty string, what we have to do? Return true. For sure, it is a palindrome. We know that a blank string is always a palindromic string. So yeah. So else, if s at 0, the first character is equal to s at is not equal to the last character. So s at -1, then it is not a palindrome. So what we have to return? So we have to return false. Finally, if s at 0 is equal to s at -1, it might be a palindromic string. Look for the return value obtained by the function called is palindrome over the list as containing the elements from index 1 up till index -1. Fine. So let's use this function. So let's open up our IDE. So let's import the function is palindrome. So let's use this function here only. So let's call this function is palindrome and let's pass in the string A, B, C, D, A, B, D. Fine. Let's see what are the outputs. Let's print the value. Let us see. So you can see it says false. So no ABD is not a palindromic string. Let's check for a blank string. So it says true. So yeah, the blank string is the palindromic string. Let's call the user for some input. Fine. So let us use the input function. Please enter a string and then is palindrome. Let's take the output in the variable is palindrome. And if is palindrome, we have to print what is the string IP, comma is a palindrome, else IP is not a palindrome. So let's run this program and see. So let me enter a string AB as some random. So it is not a palindrome. Let's me enter a blank string. Let's see. It is a palindrome. Let's enter a palindromic string ABCBA. So it says ABCB is a palindrome. Let's enter the string race car. It is a palindrome. Let's enter the string Malayalam. It is a palindrome. So this is how you write a recursive logic. This is how you think what to do, how to write recursive functions. Fine. Anyone? So you are saying can't we just check whether it's reverse? So yeah, there are various ways you can use other functions also. But this is through this example, I am trying to explain you how to use recursive, how to solve problems using recursion, how to think recursively. That's it. It's like you can solve this problem using for loops. You can solve it using this reversal, string reversal. There's there are many ways to do this, but I wanted to explain you how to use recursion to solve this problem. Fine. Anyone? Do you have any doubts? Will you be able to now develop logics for writing recursive problems, solving recursive problems? If you have doubts for this problem, just type in the chat box. So everyone, please type in the chat box if you have any doubts. So yeah, you should practice more on the recursion to get the correct logic. So please type in the queries in your in the chat box. Fine. So no one has any doubt. So let's move on to the next question. So it's really interesting problem. So let's solve this problem. Find GCD of two numbers using recursion. So every one of you is familiar with GCD, the concept of greatest common divisor. So what is the GCD of 15 and 25? Anyone? What is the GCD of 15 and 25? So basically, greatest integer that divides the numbers 15 and 25 with remainder 0. Everyone, are you familiar with this idea? So do you know the definition? So let's try to solve this problem using recursion. So what is the naive way? Naive way would be, we know it's a positive integer, so it starts from 1. Check until the smallest number, which is 15 here in this case. If it divides both 15 and 25 without remainder, then we get the answer. Fine. So it's a naive way. Let's think recursively. So we know we have a number 15 and we have a number 25. Okay. So let's see how to solve this problem. So 15 can be written as 3 into 5. Again, 25 can be written as 5 into 5. So let me write up some logic and then you think if that's correct or not. So we get the minimum of the two values. So minimum is 15, maximum is 25. Fine. Now we replace max with max minus min. Okay, so you replace 25 with 25 minus 15, which is 10. Fine. Now again compute GCD of those values. So GCD of 15, comma 10. Now you have min equals to 10, max equals to 15. You have to update max with max equals to 15 minus 10, which is 5. And we have min equals to 10. Fine. Now again we call the GCD function with 10, comma 5. Now min is 5, max is 10. You update max with 10 minus 5, which is 5. And now if max is equals to min, then we get the GCD. So this is the recursive logic that we'll be using. So what is the logic? The base case would be if max equals to min, then return max. So basically this is the answer. If else call GCD again with max minus min, comma min. So this is the simple recursive solution to this problem. So let's see. It is GCD recursive. Fine. So def GCD. Let's call some values a comma b. If let's ensure that a is always less than b. So if a is greater than b, we swap the values. So a comma b equals to b comma a. Fine. So we are here. Now, what you have to do? You have to simply call. You have to use a recursive case. Base case. We have to define the base case. base case. If and B are equal, then we get the GCD. So we have to simply return A here. Else, what we have to do? We have to return GCD of. So we have already ensured that B is the bigger value. So A comma B minus A. That's it. So let's take inputs. A equals to, let's typecast it as integer and then input. Please enter the first number. uh, And then again, let's take input the second number. Fine. And now what we have to do? We have to simply call the GCD function and print the value. Print the GCD of A and B is, let's call the function GCD over A comma B. So let's run the code and see the outputs. So let me enter the first number as 15, the second number is 25. So we all know the GCD of 15 and 25 is 5. What about 15 and 60? Oh, sorry. So 15 and 60. Oh, it is 15 and then second number is 60. So we all know the GCD of 15 and 60 is 50. Right? So this is how you write the program for computing the GCD of two numbers using recursion. Anyone, do you have any doubt? Anyone, do you have any doubt in this problem? So if you have any doubts, type in the chat box. It's almost 8, so I'll be here for 5 more minutes. If you have any queries, type in the chat box. I have few more problems. I had few more problems to discuss, but since it's already 8, so I will give those problems as homework to you guys. You can try out them on your own. Fine. So if you have any doubt, type in the chat box. Fine. So here are some other programming problems that you can solve. Right? So there is no attendance requirement for live sessions. So don't worry. All the videos will be shared online, shared with you guys, recorded videos. So yeah, that's it for today's session. Thank you.